All right, so the ln of a naught is equal to negative kt plus or minus. I already forgot. Okay, thank you. The ln of at. Now, this one, not good? Am I wrong? Oh, okay, thank you. That's the t. That's the naught. I apologize. Logarithms, it may be easier to write this one in the other way. To get the ln of a naught on the right side or the left side, you just could divide it. And I know you're like, wait, that's a minus. But if I subtract an ln, it's the same as dividing them. Does that make sense? That's just a rule from logarithm land. I didn't make it up. So this is the same equation, just written a little bit different. Anyway, go ahead and try that. It doesn't matter if you do that. It's just another way to do it that might make it easier. So the ln of at, all right, it goes from 0.13, so that's where you start, to 0.088. So that's your concentration at a specific time. So 0.088 would be right here. 0.13 would be right here. And then K is 0.33. So you're going to take all of this, divide it by negative K, right? You with me? And that should give you your time. What do we get? Newman, what did I do wrong? I did. Sort of. When you subtract logarithms, it's the same as dividing them. So I just rewrote it the other way. You should get the same answer either way.
Wait, I thought that we were subtracting the same as dividing inside. Like, the ln of at, subtract the ln of a naught would be the same as the ln of at subtracting. Or dividing by, yeah.
Check and see if it makes a difference. You're probably right. I swear it's the same value, though. Okay, Benson says it's not. Okay, so let's not shorten up the algebra then, because obviously I'm doing it wrong. So it's 0.88 over 0.13, is that what you're saying, Jeffrey? Okay. I'm fully aware that I probably screwed that up. So whatever. Either way you algebraize it, even if you subtracted, we can still do it that way. And then that's over negative 0.33 still. So if I screwed that up, I'm sorry. Did anyone have an answer, though? What did we get, Newman? 1.18?
Yeah.
All right, and that'd be minutes. Okay. All right, sorry about that. So it's not abnormal for me to screw up algebra. So it is okay to divide, but I guess you guys are right. You take the values in one, and you divide them, and then take the ln of that answer. All right. This is just, you're going to have these equations, the 0, first, and second order ones. You're just going to plug and chug to do those. All right. This is a pretty basic question. This is on the test. It's one of the multiple choice questions. So it'll take like 20 seconds and answer that. This shows you the relationship between the ln of a versus time, and that's a straight line, correct? All right, so this would tell us, by the way, it's first order, because if it's ln versus time and it's linear, it's first order. So that would mean the slope of this line is equal to negative k. Now this is a multiple choice question. Oops, that's another A. Be careful not to select K. It's equal to negative K. This is a negative slope, and K is always a positive value. Easy enough? Hopefully. All right. So this one you really need a reaction. So what's the rate of disappearance of Cl2 when the initial concentration of the reactants are NO is that, and that is that. Okay, you actually need an entire table to do this. And I won't give you that data. This is right off the test. So all you have to do is going to have your concentrations and your rate. Sorry, why did I do that again? And your rate. All right, and you'll have figured the rate law out, and you just plug those back in. Once you have the rate law, so let's say that rate, that's a P. Cold medicine on, it's awesome. The rate is equal to K, let's just say it's Cl2 and NO. Now this is on your test tomorrow. I have no idea if that's right or wrong, so don't memorize this by any means. And let's say that you know K is 1.8. Then, all right, I'm not even doing this right. I knew it wasn't that hard. Okay, hold on. We'll just say A plus Cl2 goes to NO plus B. I'm sorry. What I was just telling you is certainly a fine thing to do, but not for this problem. It's easier than that. Let's say when we balance this out, you have a 2 and a 1. This is just a stoichiometry question. All right? So the rate of disappearance of Cl2, it doesn't even matter what happens here. It's 2 times greater than NO. That's all we need to know. He's not here today. He comes like once a week. And I know I haven't marked him absent yet. Okay? So the disappearance of Cl2 would be 2 times greater than NO. That's all you have to write. Is that okay? If it's a different coefficient, you would do it differently. Say 3 to 1 or 1 to 3 or whatever. Okay. There is a problem that we'll do that's like the one I was just talking about. All right, this is a multiple choice question. Take a second and solve that one, if you will. You can get one right for the first time in the last 2 problems. All right. So is K the rate constant? Yes. Is the reaction second order according to B? Yes, thank you. Is it first order according to A? Yes. If B is doubled, the reaction rate will increase by a factor of 4. Yeah, that's true. That's what the 2 means. The reaction is second order overall. That is false. F, the reaction is third order overall. That would be true. The overall reaction, you just add the exponents. If there isn't one, it's a 1. Okay. Back on a winning streak here. Okay, next. Ooh, that's kind of blurry, but hopefully you can read it. There's a few seats close if you need. All right, the reaction of that is believed to be, it follows this 3-step process. Here's your slow step. This is really close to 1 on the test, so give that a couple minutes of consideration. Slow step, whenever I see that and there's something after it, I just get rid of it right off the bat, so I don't even consider using that. All right. Write a balanced equation for the overall reaction. All right, so I'm going to come up here. Now, I shouldn't have done that, I guess, because we do need to be careful. The overall reaction is all of this stuff. Okay, which I haven't talked about yet. Like, I mean, we have, but not really. So you get rid of any intermediates. N2O2, N2O, N2O. And then everything else is left. So that's the overall reaction, but that's not the rate law, okay? The overall reaction involves everything here. So it would be 2NO plus 2H2 goes to N2 plus H2O, 2H2O. Are you okay with that? So I gotta be careful. I just crossed it out myself. The overall reaction includes everything you see here except for intermediates. Alright? But the reaction rate and laws, they only go what's slow and before. So we'll come back and get rid of that now. Alright, so we did that. The intermediates would be the N2O2 and the N2O. Is that okay? Alright, from the mechanism represented above, the AP test does a ton of these, by the way. A student correctly deduces that the rate law for the reaction is KNO2. That makes sense because there's NO to the second is what I should have said more clearly. There are two NOs. Alright, and then just the plain H2 raised to the first. Alright? The student then concludes 1, the reaction is third order, and 2, the mechanism involves the simultaneous collision of two NO molecules and an H2 molecule. Are conclusions 1 and 2 correct? Explain. So will you take a second and talk to your lab partner and see, are those two things correct? Pretty good discussion. We both agreed number 1 was correct. Does everyone agree with that? It's third order because there's a 2, there's a 1. You add those, you get a 3. And then I asked Emily, and she said this one is probably not correct, which is right. That almost was confusing. All right, number 2, that conclusion is incorrect. And the reason why is up here. These are individual steps. Okay, we don't care about this one, but whatever. So in this part of the reaction, these two things had to collide. Once they collided, they made an N2O2. And then in this step, the N2O2 thing then collided with an H2. Alright, they run into each other. And there you go. So really, two things ran into each other to form one. And that one thing that was now two parts ran into the third thing. So never were three individual things running into each other. If there was, this would say this. It'd be NO plus H2 goes to. The only way to have three things collide simultaneously is if they're all three in the same step. That was probably a lot easier way to say it there at the end. You're welcome for my great oratory skills. All right, this one's a little bit tricky. Explain why an increase in temperature increases the rate constant given the rate law in C. If we know rate equals K NO2 H2, we know the rate will increase as we increase the temperature because that happens. But temperature doesn't affect these. Okay, so since the rate goes up, K has to go up as well. All right, and K accounts for the increase in the number of collisions. All right, K is temperature dependent. Now, there's no temperature in the unit. It's just that K is different for every single temperature that there is. I know that's weird, but there you go. And I don't have you explain one of those on your exam. Okay, next. This is another one. Give this a shot for a minute. All right, overall reaction. So once again, the reaction includes everything except for intermediates. It looks like HOI definitely disappears. The OHs, there's 1, 2 on the right and 2 on the left, so they're going to disappear. No. Aren't they on the same side? So the I minuses are on the left. The I2 is on the right. And I know, I get that, but they are not the exact same. So that's actually a really good point there. All right, so we're going to have HOOH plus 2I minus plus 2H3O plus goes to I2 plus 4H2O. You okay with that? All right. It's not a catalyst. That's a really good question, by the way. But it's not a catalyst because it did change in the reaction. It went from an ion to an actual compound. Well, not compound, molecule, whatever, but it's acting like it sort of acts like a catalyst, but it is not exactly one. Okay, the intermediates then are HOI and OH minus, is that right? The rate law based on this mechanism, so we only care about the slow, which is the first, so that's really nice. So rate equals K HOOH and I minus, right? Okay with that? And the overall order, it was just a 1 and a 1. Okay? If the second one was slow, it'd be a 1 and a 2. So I guess it said the overall, so the overall is 2, because they're both 1s. Okay, are we confident with those? Okay. Next up. All right. I spent most of my morning making this data table up. And I hope I typed everything in right so it does work. It's a huge pain in the butt to make these up, but I made it up. Now, this is a problem that's extremely similar to the test. I changed these. I changed these. But pretty much that's it. Okay, A is not on here, and that's fine. Okay, this is the last review question, so give this a shot. This would be time. This is concentration. All right, so when you graph, this was the ln of, that doesn't look like an ln, but I don't even care. This was the ln of L2, and this is 1 over L2. These should have been like 4.55, I don't remember what it was, but it was linear, right? That's how I made it up. Anyway, so we know it's first order, essentially. So then the value of the rate constant, that's just equal to the slope, which we found with our calculator by Calc 4 or whatever, right? Linear regression, hit enter a bunch of times, and the value of the rate constant is equal to 2.49. Oh boy, sorry. Thank you though for volunteering your answer. 0.05. All right. So if your calculator lies to you like that, there's probably another line in your calculator somewhere. Because the calculator doesn't screw math up, but it's not giving you the slope of that line. Does that make sense? All right. So then, what would the half-life of this reaction be? So first order half-lives, so T 1/2, and that just means the time at 1/2 is equal to 0.693 over K, correct? All right, so 0.693 divided by 0.05, is a number. What's that? 13.86. All right, and that would be minutes. Okay, now come right here and check if that's reasonable. Does that seem reasonable? Yeah, definitely, because the half-life is between these two values, and that time is between those two values, so that's good. All right. E, what would be the half-life if we started with twice the concentration of dinitrogen or nitrogen pentoxide? And the answer would be 13.86. It's the same, correct? Explain your reasoning. All right, this is the way that the AP testers would test that you know that the half-life for a first-order reaction is independent of your initial concentration. Looking at the math equation, another way to say it is A naught is not part of the half-life equation for a first-order reaction. Okay? That doesn't seem to make sense. You're like, hey, you have more stuff, you have a faster rate. That's okay. The rate is faster, but you still had more stuff. So in the first order, those two things cancel each other out, and the half-life stays the same forever. What's that? It is independent of the initial. Now, if this was, and we know it isn't, but let's say it was second order, these numbers are not the same anymore, right? Because in second order, the half-life equation, and it's on that little sheet, it has 1 over K times A naught equals T1 half. So for second order, it is dependent. Okay? All right. F. How long would it take for the concentration of N2O5 to reach this? Now, if I don't edit the test, which I certainly don't plan to, one of the biggest problems with this whole test is I make you write out the reaction and you don't remember the formulas, but look, I typed it in there on accident. How long would it take for this to reach that if the initial concentration of that was that? So this is the integrated rate law, right? Where you just solve for T. Now, we did this earlier and I screwed it up, so why don't we do it together just to make sure I feel good about my life. All right? So let me scroll down and get a little bit more room here. And I'll make sure and write this. So the ln of AT, correct, is equal to negative K times time plus the ln of A naught. Okay, now, when I tried to use what I thought I remembered about logarithm tricks, it didn't work, so I'm not going to this time. I'm just going to plug things in and make them a number. All right, so AT would be the one at the particular time. So I have the ln of 0.008, whatever, equals negative K. K was 0.05, is that right? So negative 0.05 times T, which is my variable that I'm solving for, plus the ln of A naught. A naught, it gives me, is right here, 0.035. Okay. Then, Benson, do you have this number calculated? Well, no. K is positive. That is true. But in this problem, it's negative. I'll get there in a second. Okay, thank you. And then what's this piece right here? Thank you. Someone said my name? What? Okay. All right, so I have a plus minus, which is really just a minus, correct? So I'm going to add. Are we okay with that? 3.35. We okay with that? All right. So, and then I'm going to take this thing and divide it by negative 0.05, and that will tell me what t is. I get 29.6. Anyone back that up? Awesome. Thank you for it. Did you get that number in your calculator? You know what you did wrong? Okay. Hey, Emily asked me a question that I think is super important. On the calculator, when you found the slope was negative 0.005, or what was it? Okay? It was that in the calculator. But remember, that means k is actually positive 0.05. But in these problems, we do keep that negative, but we don't negative it. Okay? It's tricky. But don't make it positive because it was negative on your calculator. All right. If you can do that problem, then you're ready. Let me just tell you quickly the format. So this test has more multiple choice than normal. I think it has like 18 multiple choice. Of the 18, I think you've seen 16 of them in class, either today or as we went along. Okay? So it's not that bad. And then it has 3 free response questions. The 3 free response are initial rate tables, initial rate tables are the ones with 3, essentially. It's not an ICE table. It's okay. It's concentration, and rate. You know what I mean? So we double one, we see what happens. We double the other, we see what happens. Okay, so one of them is that. The other free response is like the one we just did. That table will only be 2 wide. All right? That still looks dumb, I guess. But that one will be time versus concentration. All right? We just did that one. That's your ln or your 1 over. Okay? Your concentration. And then the third one is a mechanism. Question. Time-wise, this one literally takes 2 minutes. This one with the integrated rate law parts probably takes 10. And this one probably takes a maximum probably of 8. So that's 23. You have time to do the multiple choice. When you get it, it will look like a really long test. But if you know how to use the calculator and you're pretty good at it, some of you will get done very fast, even though it's a long test. Okay, any questions?